Dear children, today we will start the first chapter of physics, that is physical world. So what is meant by physical world? What is meant by physics? The scope of physics, everything it is mentioned in a textbook. You can read those topics. Okay. So in that the main important topics that we are discussing here, which are those topics that we will see one by one. First one is fundamental force and second one is properties of fundamental force, and next we will discuss about conservation laws. Okay, so three topics today we will discuss: fundamental forces, properties of fundamental forces, and conservation laws. So first of all we will discuss the fundamental forces in nature. We are familiar with various types of forces, no? Various types of forces you have studied from smaller classes onwards: frictional force, Coulomb, gravitational force. So many forces you have studied, no? So which are the fundamental forces that we will discuss? So there are four fundamental forces. Among them, first one is the gravitational force, and next one is electromagnetic force, then strong nuclear force and weak nuclear force. So there are four fundamental forces: gravitational force, electromagnetic force, strong nuclear force and weak nuclear force. Among them, you have already heard about gravitational force, no? So first of all we will discuss about gravitational force only. The expression for gravitational force also you have studied. F is equal to G into m1 into m2 by r square. What is G? G is universal gravitational constant, and here I have used a small m and capital M. Small m and capital M both are two masses, and r is the separation between the center of those masses, no? The separation or distance between the two masses is r, and F is the force. So the expression for gravitational force is given by G into m by r square. So how this gravitational force arises? This arises because of the virtue of the masses, no? The force of mutual attraction between two bodies by virtue of their masses is known as gravitational force. Okay. The force of attraction between two bodies by virtue of their masses, it is known as gravitational force. Now let us see which are the properties of gravitational force. Okay. So the first property is it is attractive force. It will be always attractive. Okay. Whatever may be the value of the masses, the forces between two objects will be always attractive in nature. And second one, it obeys inverse square law. So what is meant by inverse square law? So from the expression itself it is clear that F is equal to G mm by r square. Here force is related with distance as the square, inverse square, 1 by r square, no? So wherever force and distance relation is, F is inversely proportional to r square. F is equal to some quantity by r square. Then we can say it as inverse square law. Okay. So it is an inverse square law force. Then it is a long range force. Long range force means whatever may be the distance between the two objects, the forces will be acting. Okay. If whether it is very much closer or if it is very far away also, the forces will be acting. That's why it is known as long range force. Is it clear? Long range force means whatever may be the distance between the two objects, the forces will be acting. Such type of force or such property is known as long range force. And it is the weakest force in nature among the four forces, no? We have seen gravitational force, electromagnetic force, strong nuclear force and weak nuclear force. Among these forces, these four forces, the weakest force is the gravitational force. Then it is central force. So what is meant by central force? It is acting along the line joining the two objects. Okay. The force will be acting along the line joining the two objects. That's why it is known as central force. It is acting towards or along the line joining. Next one, it is conservative force. Conservative force means a force is said to be conservative if the work done by the force depends only on the initial and final positions and does not depend on the path taken. If you are taking an object from A position to another position B, so it matters only which are the position, does not matter through which you are going. Whether you are going through a straight line path, whether you are going through a curved path, or whether you are going through a triangular path, doesn't matter. It depends only on the initial and final position. Okay. Such force is known as conservative force. So you understood what is meant by conservative force, no? So these are the properties of gravitational force. Okay, is it clear? So these are the properties of gravitational force. Okay. Now so one more what property is that the exchange of particles during the interaction is called graviton. The particles exchange during the interaction of gravitational force is known as graviton. Okay, so that we will discuss later on in the chapter. Gravitation chapter is there. In that we will discuss it in detail. Okay, is it clear? Next we will discuss about electromagnetic force. So the force between two charges at rest, it is known as electrostatic force. The force acting between two charges which is at rest, that is known as electrostatic force. So the expression for electrostatic force is given by K into Q1 into Q2 by R square. K is a constant. Q1 and Q2 are the charges and R is the distance between the charges. Okay, that force is known as what is electrostatic force. Similarly, force between two magnetic poles, it is known as magnetic force. Force between two magnetic poles is known as magnetic force, and this electric force and magnetic force are interrelated. Why? Because a moving charge can produce magnetic field, and whenever a charge is kept in a magnetic field, it experiences a force. That already we discussed in last year. No, a moving charge can produce magnetic field, and when a charge is kept in a magnetic field, it experiences force. So this electricity and magnetism are interrelated, and hence it is known as electromagnetic force. Okay, now we will discuss the properties of electromagnetic force. The first property is that it may be attractive or repulsive. If there are two like charges, two positive charges or two negative charges, the force will be repulsive, and if one is positive and another is negative, it will be attractive. Similarly, like poles repulse and unlike poles attract. So here in this case we can say that it may be attractive or repulsive. Next one, it obeys inverse square law. So what is meant by inverse square law? Just we discussed. If force can be written as some term in by r square. No, if is inversely proportional to r square, in that case we can say that it is inverse square law. So this is also inverse square law force, and this is also long range force. So whatever may be, in whichever may be the separation between the charges, the forces will be acting. So it can be up to any distance, the force will be existing. That's why known as long range force, and it is central force, again similar to gravitational force, which means it will be acting along the line joining the charges or line joining the poles. Then it is conservative force, already we discussed. Work done depends only on the initial and final position and does not depend on the path taken. And next property is it is 10 raised to 36 times stronger than the gravitational force. So it is stronger than gravitational force. Okay, understood? But it is not the strongest force, it is stronger than gravitational force. 10 raised to 36 times stronger than the gravitational force. And here the particles exchanged is known as photons. The particles exchanged during electromagnetic force of interaction. The particles are known as photons. That we will discuss detail in the coming chapters. Okay. Next is meant by, what is meant by strong nuclear force. So from the word itself clear that it is strong force and it is nuclear force. Nuclear force means it is acting only inside the nucleus. Or we can say that the force acting between two protons or two neutrons or one proton and one neutron inside the nucleus, that is known as strong nuclear force. A strong attractive force which binds together the protons and neutrons in a nucleus. We know that like charges will repel. So proton should repel. But by overcoming that repulsive force, these protons are comfortably staying inside the nucleus because of the strong nuclear force. Okay, is it clear? Now we will discuss the properties of nuclear forces. It is 10 raised to 38 times stronger than the gravitational force. So we can say that this is the strongest force in nature. It is 10 raised to 38 times. You can see that how much large it is. Then it is short range force. It will be acting only inside the nucleus, which means 10 raised to minus 13 or minus 15 meter. Within that small distance only this force will be acting. Okay. It does not obey inverse square law. It obeys some other relation that we will discuss in next year. So it does not obey inverse square law. And it is non-central force. It is not acting along the line joining, and it is not a conservative force. Okay. Is it clear? And another important property is that it is charge independent. Charge independent means it does not depend on the charges, which means the force between two protons, force between two neutrons, or force between one proton and neutron all will be same. Okay, does not depend on the charges. In the case of electrostatic force depends on the charges. Like poles repel each other, unlike poles attract each other. If there is no charge, there is no electrostatic force. But here, in the case of strong nuclear force, does not depend on the charge. Whether it is two protons, whether it is two neutrons, if it is one proton and one neutron also, the force will be same. Okay. And here the particles exchange during the interaction is known as pi mesons. Okay. The particles exchange during that interaction called as pi mesons. Okay. So these are the properties of strong nuclear force, and now we will discuss about weak nuclear force. The force that appears only between the elementary particles involved in a nuclear process. This force is acting only between the elementary particles in a nuclear process. Okay. In nuclear process only these forces will come into play, not in the normal situation. Okay, only in the nuclear reactions these forces will come into play. And these processes involving always neutrino and antineutrino. These are two particles. We will discuss detail next year. So there are particles, various types of elementary particles are there. Two among them are neutrino and antineutrino. Wherever neutrino and antineutrino are involved in any reaction, in any nuclear reaction, their nuclear force will be that weak nuclear force. Okay. Then it is caused by the exchange of vector bosons. The particles exchanged during the interaction is known as vector bosons. Okay. And it is 10 raised to 25 times stronger than the gravitational force. Okay. This is 10 raised to 25 times stronger than the gravitational force. So we can say among the four forces, the strongest force is, which is the strongest force? Strongest force is strong nuclear force, and the weakest force is gravitational force. After gravitational force, next comes weak nuclear force, then comes electromagnetic force, and then comes the strong nuclear force. Okay, is it clear? Now we will discuss about conservation laws. These conservation laws already you have studied in 9th, 10th, all those classes you have studied. So there are mainly 4 conservation laws. So first of all we will starting with the law of conservation of energy. So what law of conservation of energy says? Energy can neither be created nor be destroyed. It can be transformed from one form to another form. Okay. Or in other words, we can simply say the total energy of an isolated system remains constant. Total energy of an isolated system remains constant. So if you are considering an isolated system, its total energy will be always constant. Various examples of law of conservation of energy already you have studied. If you are switching on light, electrical energy is getting converted into light energy and heat energy. So there is no violation of law of conservation of energy. Any process which is taking place in nature will be always following law of conservation of energy. Okay. And next one is law of conservation of charges. So what it says, total charges of an isolated system remains constant. Charge can neither be created nor be destroyed. Here also. That already we have discussed in 10th standard. No, total charge of an isolated system remains constant. Okay. And next one what it is? Law of conservation of linear momentum. So that what it says, if no external force is acting on a system, then its linear momentum remains constant. If the external force acting on a system is zero, we can say the total linear momentum is constant. No need to worry, all this we will discuss in one or other chapter in detail. Simply just for the namesake we are discussing this. Okay, in detail its expressions, formula, everything we will, and examples, problems, everything we will discuss in the coming chapters. Okay. And the last conservation law is law of conservation of angular momentum. So what it says, if no external torque acts on a system, then its total angular momentum remains constant. If external torque is not acting, its total angular momentum remains constant. This is related to rotational motion. In translatory motion, we are telling about force. In normal rectilinear motion, we are telling about force and linear momentum. In rotational motion, in terms of force, we will use another term known as torque. And in terms of linear momentum, we will use the term angular momentum. Okay. So this is about the first chapter. So you can go through the entire chapter, you can read the chapter, and you can study what is meant by physics, what's the scope of physics, where physical laws are applied, all those given in detail, and about the contribution of different scientists, which scientist contributed for what, all those you can read in detail. And if you are having doubt, you can contact me. Okay, is it clear? Thank you.